Graphing a cosine function. The question we are doing can be found on page 344, number 3 of the Nelson Advanced Functions textbook. The question is to identify the key characteristics of y equals negative 2 cos 4x plus pi plus 4 and sketch its graph. Here are the steps to complete the question. First, we need to factor out the b value of our equation. Secondly, we need to identify the amplitude, period, equation of axis, and horizontal translation. 3, we need to convert the basic cosine table of values from degrees to radians. 4, we need to make a table of values for transformations. 5, we need to graph the transformations. And finally, we need to check the graph using Desmos. Before we can graph the function, we need to understand the characteristics of a cosine function. Below is the equation for a sinusoidal function, y equals a sine or cos, square bracket b, round bracket x plus h, round bracket, square bracket plus k. So first we've got our a value here. This is our amplitude. Amplitude is half the difference between the maximum and minimum values of a sinusoidal function. Note the amplitude is always positive. So looking at this graph, we can see what the amplitude is. So from here to here, that's our amplitude. Then we'll know if it's sine or cos depending on what the question is asking for. Then here we've got our b value. This is our period. To find the period, it's 2 pi divided by the b value. A period is a change in the independent variable, typically x, which corresponds to one cycle of a sinusoidal function. So in simpler terms, before it starts repeating itself. So looking at this graph here, this is the period, because from here to here is 1, and then it starts to repeat itself from this point. Then we've got our h value here. Our h value is our phase shift, so it tells us if the function is being translated to the left or right, depending on this sign here. If it is positive, it's moving to the left, and if it's negative, it's moving to the right. And then over here, we've got our k value, which is our equation of our axis. This is the equation given to us in our question, y equals negative 2 cos 4x plus pi plus 4. So if you notice, we've got our a value here, x, h, and k. However, we're missing our b value, so what we need to do is we need to factor this 4 out. So now we've factored out our 4, so we've got a b value, but we want to keep the equation above the same. So we need to find something that multiplies by 4 to give us pi. So now we've got negative 2 cos 4 bracket x plus pi over 4 bracket plus 4. So it is the same equation as above, it is just factored out. So 4 times x gives us 4x, and 4 times pi over 4 gives us pi. But now we've got all our values. So it is the same equation, just factored out. So when you need to find this equation, all you have to do is factor this out to get a b value. Using this equation, we can find out the characteristics of our graph. So we said that our a value was this one right here. And we said that our a value is amplitude, which is always positive. So our amplitude is 2. We said our b value was our period, and we said the period was 2 pi divided by our b value, so 2 pi divided by 4 gives us pi over 2. We said this was our phase shift, or horizontal translation, and we said if it's positive it moves to the left, so it is horizontally translated pi over 4 to the left. And then we said that our k value was our equation of axis, so y equals 4. Because our equation tells us it's a cosine function, we need to understand what a basic cosine graph looks like. So to the right, we've got our graph. This is before any transformations are made. And to the left, we've got our basic cosine table of values. We need to understand how to make the table of values to represent our transformations. So on the left here, we've got our basic cosine table of values, which we just looked at. And then we'll make a second table of values to represent transformations made from our b and a values. So we take our x and we times it by the reciprocal of b, which is typically 1 over b. Then our y values we multiply by our a value. Then on our third table of values we take our x and we plus or minus our h value, and then y plus or minus our k value. Before we graph the equation, we need to convert from degrees to radians. So to the left here is our basic table of values for a cosine function. but we want to convert it into radians since our equation was given to us with pi, which means that we need to graph in radians. So to convert to radians, it's times pi over 180. So 0 times anything is 0. 90 times pi over 180 gives us pi over 2. Before we said that our second table of values, it's x times 1 over b, and our b value is 4. So it is x times 1 over 4. So 0 times 1 over 4 gives us 0. Pi over 2 times 1 over 4 gives us pi over 8. Pi times 1 over 4 gives us pi over 4. 3 pi over 2 times 1 over 4 gives us 3 pi over 8. And 2 pi times 1 over 4 gives us 2 pi over 4. Then for our y values, it's times our a value. So y times negative 2. So 1 times negative 2 gives us negative 2. 0 times negative 2 gives us 0. Negative 1 times negative 2 gives us 2. 0 times negative 2 gives us 0. And negative 2 times 1 gives us negative 2. This is the math. If you don't understand how to do it, it's basic multiplication of fractions. So multiply the numerators together and multiply the denominators together. So the first one was pi over 2 times pi over 4. So pi times pi gives us pi, and 2 times 4 gives us 8. Then our third table of values is representing the transformations made from the h and k value. So we said it's plus or minus h. So because this one's positive up here, it becomes negative in our table of values. So it's minus our h value, minus pi over 4. So 0 minus pi over 4 gives us negative pi over 4. Pi over 8 minus pi over 4 gives us negative pi over 8. Pi over 4 minus pi over 4 gives us 0. 3 pi over 8 minus pi over 4 gives us pi over 8. And 2 pi over 4 minus pi over 4 gives us pi over 4. Then our y values are plus or minus our k value. And because it's positive here, it's positive down here. So plus 4, plus 4. So negative 2 plus 4 gives us 2. 0 plus 4 gives us 4. 2 plus 4 gives us 6. 0 plus 4 gives us 4. And negative 2 plus 4 gives us 2. So here's the math if you don't understand how to do it. So we're going to look at the second example for our x values. So it's just addition and subtraction of fractions. So you have to make the bases, the denominators the same. So pi over 8 minus pi over 4, we need to make the denominator the same. So 4 times 2 gives us 8. Times 2 on the top, we have pi over 8 minus 2 pi over 8 gives us negative pi over 8, which you'll see right here. And it is the same for the rest. Using the table of values that we just created, we can graph our equation and our transformations. So here we've got 0 and 6, pi over 4 and 2, pi over 2 and 6, 3 pi over 4 and 2, pi over 8 and 4, negative pi over 4 and 2, negative pi over 2 and 6, and it continues. So now we can check Desmos to see if we are correct. We've got 0 and 6, pi over 2 and 6, we've got 3 pi over 2 and 6, pi over 8 as 4, pi over 2, so we've got basically the same points, so it looks very similar. And we can check by seeing if our characteristics are the same as the ones that we created from our equation. So we said that our amplitude is 2, and our amplitude is from this point to this point. So 6 minus 4 is 2, so our amplitude is correct. We said our period was pi over 2, so our period is from this point to this point, which is from here to here. So pi over 2 minus 0 equals pi over 2, so our period is correct as well. And then we said our horizontal translation or phase shift is pi over 4 to the left, so you can just pick a point like this one, for example. So from here to here, it is shifted negative pi over 4, so from here to here, pi over 4 to the left. So it looks correct. So, and then this one over here is our basic cosine function. Careers in this field could be people that are involved with weather network and such, because they like to graph the temperatures. So this is an example of graphs from the weather temperature, and they need to use sinusoidal functions to do so.